Hi friends. See, last time we discussed about law of conservation of energy, that is about freely falling bodies. Today we will be discussing about the law of conservation of energy in the case of vertically projected bodies. So first of all, let us see what is meant by law of conservation of energy. See, according to Einstein's theory, energy can be neither created nor destroyed. The total energy in the universe is constant, and energy can be transformed from one form to another form, that is potential to kinetic, kinetic to potential, mechanical to sound. Okay, like this you can transfer the energy. Okay, now today we will be discussing about the vertically projected bodies. In the case of vertically projected bodies, how the energy remains constant at any point in the journey. So first of all, for that you can see the figure here. I have drawn a figure, a building of height h. The total height of the building is taken as h from the ground level. You can consider whether it is a building or a tower. The total height of the building is h. Now I will be starting at the ground level first of all, because we are traveling from ground to highest point. So in this case we have to prove from the lowest point, intermediate point and the highest point. So first of all, at A we will find out the potential energy. So at A, P is equal to, what is the formula? mg into h. That is equal to m into g into, at A, that means at the ground level height is 0, therefore 0. Now K, at A, kinetic energy, that is equal to half m v square. That is equal to half into m into, what is the velocity, initial velocity of the body projected? V. Therefore v square. That is equal to half m v square. Now we will find out the total energy at A, ground level. That is total energy at A. That is equal to potential energy plus kinetic energy is equal to, potential energy already at A is 0 plus kinetic energy is half mv square, which is equal to half m v square. Put it as equation. So what you have done is, at A, that is at ground level, you have found out the total energy, which is in the form of kinetic energy, that is half m v square. Now what we will do is, let the body has travelled vertically from A to B, say, over a displacement of x. Now during its travel, as the body is going to the higher level, certainly the velocity increases. So let the velocity at point B be v1. Okay na? Therefore now at B, we will find out the potential energy at B, P mg h. That is equal to m into g into height. So what is the displacement here? X. Therefore into x. That is equal to mgx. So we have found out at B the potential energy. Now we will find out the K. At B, kinetic energy is equal to half m. What is the velocity at point B? v1. Therefore half m v1 square. But we don't know v1, we have to calculate v1. So for that what I will do is, because the body is traveling in upward direction, A is taken as minus g, displacement s is equal to x, initial velocity u is equal to v, and the final velocity v is equal to v1 at v. Substituting all these values in the equation, v square minus u square is equal to 2as, therefore v means v1 whole square minus v whole square is equal to 2g, of course minus, because it is going in upward direction, displacement x. Therefore v1 square is equal to, take it to the right side, what happens? V square minus 2gx. So this is the velocity at the point B. Now we will find out the kinetic energy. Therefore K is equal to half into m into v1 square. v1 square means, already we got it as v square minus 2gx. So that is equal to 1 by 2 m v square minus, if you take inside, m by 2 into 2gx. 2 will be cut off, therefore half m v square minus mgx is left out. So this is the total, kinetic energy at point B. Now what is the total energy at B? So at B, total energy is equal to P. So you can see here, what is the P here? mgs, PE plus KE. That is equal to, PE already we calculated is mgx plus K, that is half mv square minus mgx. So minus mgx plus mgx gets cancelled, therefore we got it as half mv square. Put it as equation. Now you can observe very clearly that equation 1 here half mv square, equation 2 is also half mv square, both are same. So at A and B already approved, the total energy is constant. Now what I will do, at C I will find out. Okay, so at C, that is highest point. So when the body is traveling vertically to the highest point, at the highest point the final velocity is 0. Therefore at C, first of all, again P, potential, that is mgh, that is equal to mg into height, from A to B height is h, that is equal to mgh. Okay, so I have calculated the potential energy at highest point. Now what I will do is, I will calculate the kinetic energy. So Ke at C is equal to, what is the formula, half m v square, that is equal to half into m into, at the highest point the velocity was 0 after reaching to the highest point, therefore 0 whole square is equal to 0. So total energy is equal to Pe plus Ke, that is equal to, already potential energy we calculated as mgh plus Ke we got 0. But what happens here is, since the body is traveled from A to highest point, there is a displacement of h. Therefore, you can calculate the displacement equation like this. That is, A is equal to minus g, initial velocity u is equal to v, and final velocity v is equal to 0, and s is equal to h. So if you substitute again, once again, v square minus u square is equal to 2as, v highest point 0 whole square minus v whole square is equal to minus 2gh. So both side minus gets cancelled. V square is equal to 2gh, or h is equal to v square by 2g. Now substituting this value here, so what happened in the place of mgh, we will get in this form, you will see here. So above already we got total energy. Total energy is potential energy, that is mgh. So in the place of h I will substitute as v square by 2g, plus already kinetic energy is 0, therefore 0 is equal to, you can see here, you can carry mg, gg gets cancelled, so half m v square plus 0, which is equal to half m v square. Put it as equation 2. So now you can observe from equation 1, 2 and 3 towards the journey from A to the highest point. From equation 1, 2 and 3 you can see all the energies are constants, which is in the form of kinetic energy. Therefore, with this it is very clear that in the case of vertically projected bodies, the total energy is remaining constant throughout the journey from A to C. Hence, the law of conservation of energy is proved in the case of vertically projected bodies.